we're going to do um, a quick little tutorial here on solution chemistry. And there's probably more to it than meets the eye. I'm going to keep my timer going here. Okay, so first of all, why is solution chemistry so important? A couple things to talk about is that the drop of water is the greatest, is really the greatest chemical container on the planet. Good news is it's number one way we can transport chemicals. Bad news is that sometimes you get chemicals in there that we don't want in there, and that leads to pollution. General terms you're going to need to know. Solvent. This is what does the dissolving. Most of the time, we will talk about water, but that is not the only solvent around. The solute. This is what gets dissolved. When you think of salt water, it's that's definitely the salt is the solute. Solvent is the water. Solubility. This has a very specific quantitative meaning. Most of the time, it's the maximum amount of solute in a very specific amount of water at a given temperature. And usually it's 100 grams of solute I'm sorry, 100 grams of solvent that they're going to put it in. For gases, it might be a bit different. Sometimes it's parts per million, but so it'll say this many grams of solute is dissolved in 100 grams of water at a certain temperature. Usually it's not reported as one number, it's two numbers disguised as one number. And again, going back to what we've done before, likes dissolve likes, and usually polar dissolves polar, non-polar dissolves non-polar. Now, basically, here are some terms that you're definitely going to need to know. Number one, unsaturated, saturated, and supersaturated solutions. We'll do some examples of these in class. Okay, so first of all, if something is unsaturated, that means that given the amount of solvent and temperature present, that it's still able to dissolve more of the solute in the solvent. A saturated solution means given a specific amount of solvent and temperature, we've maxed out the maximum amount of solute that can be dissolved in there. Supersaturated is when we've tricked it. It means it should be saturated. We should not be able to dissolve any more of the solute in the solvent, given the volume and the temperature, but we have, and it's very unstable. So what does this look like on a graph? If you look up here, and here's the best example, the way I would read this, anything on this line right here means that this is where the solution is saturated. So at 60 degrees Celsius, I can put about 110 grams of KNO3 in 100 milliliters of water. That's the maximum amount that will go in there. If I'm down here on the graph, this means that there's 50 grams of KNO3 in 100 grams of water. Remember, it's always two. There's always two. It's always two terms there. And there's always, so it's like solute over solvent at 60 degrees Celsius, but we can still dissolve more in. Anything above here, it's supersaturated. Either all the material here won't dissolve, or if it is dissolved, it's very, very unstable. And I've tried to show that by clearly identifying, at least I tried to, what a saturated solution is on the line. Anything below is unsaturated. And these are solubility curves for every kind of compound. And you can see that most cases, as we heat water, we can dissolve more in. But imagine having warm water and you put in some sugar in there, and then you cool it. Okay, as it cools down, all of a sudden it becomes saturated or supersaturated, and then the solid part that won't dissolve falls to the bottom. So this is very symbolic in nature. Okay, so that being the case, let's now take a look at ionic equations. This is a big one. Okay, so this is the one. Let me just make sure we're still here. Okay. So we're going to have to learn how to write in solution net ionic equations. This is the symbolic version. If you're going to be taking AP, you have to be able to do this. Okay. So step number one, make sure to write the complete balance equation. So we're talking about net ionic equations. So step number one, you got a balance equation. Whatever they give you, if you can't balance the equation, it ain't going to work. Okay. So step number 2, you've got to know your solubility rules. Tell me what's the solid and what's aqueous. Now, that's step number 2. That's key. Okay, so we have to know that. Or if it's a gas or a liquid. Okay. Balance state symbols. Huge. Going down to the next one. Okay. Now, anything that's aqueous, if it's a metal, non-metal ionic compound, we can break those up into ions, and we need the number of ions and the total charge. So for here, we know nickels plus 2, seals minus 1, and I've got 3 of those. Ignore the interruption. I'm going to keep going. Number 4. Okay. Okay, so now, if you notice here, we have 3 nickels, 6 chlorides, 2 chromiums, and 6 chlorides. And here it is. Okay, here it is. So down here, there's my solid. That won't change. These are aqueous ions floating around, reactants, products, and then here's my solid nickel. Now, let's knock out the spectator ions. And what's a spectator ion? Essentially, a spectator ion is anything that's the same on both sides. So we have the nickel. These are the only 2 spectator ions. These are the same on both sides. Now, so let's get rid of those. And then what we have, this is the complete ionic equation. Once we get rid of those, we knocked out the spectator ions. We have the total net ionic equation. In a nutshell, that's how we write out net ionic equations. Think of spectator ions as like when your parents take you to a sporting event. They don't really do anything. They just watch before and after. You, however, totally change, right? You get all excited. You start as one person, then you're doing the event. And when you come back, you're exhausted, smelly, and tired. Those are the reactants and products. But the ions that don't change, those are the spectator ions. So to be able to do net ionic equation, balance first. Make sure you know your solubility rules. State symbols have to, we got to use state symbols and solubility rules. Make sure that if you can write out the ions and know the polyatomic ions as well, and then you write out all the ions that are aqueous, not liquids, not solids, not gases, but just the ones that are, make sure to write those out separately in the numbers, and then cancel out the spectator ions. And that's it. So just to review, you need to know the solvent, the solute. We need to know that solubility is usually amount of solute in a given amount of solvent at a specific temperature. It's actually 2 numbers: saturated, unsaturated, and supersaturated. And then hopefully you know how to write the net ionic equation, or at least the beginnings of how to do net ionic equations. Thank you very much. If you have any questions, don't be afraid to ask.